Good morning, class. We are looking at section 3, properties of trigonometric functions. So we looked at angles and their measures, trigonometric functions, unit circle, and now properties of trig. So we are going to look at the domain, range, and period of trig functions, determine the sign of trig functions in a quadrant, find the values of trig functions using fundamental identities, and find the exact values of trigonometric functions of an angle given one of the functions and the quadrant. Use even odd properties to find the exact values of the trig functions. So that's the synopsis of what we will cover. So I'm reminding you of what we did. We looked at a line versus a ray, which is in essence half line, the vertex. The initial side along the x-axis, then the terminal side counterclockwise is positive, clockwise is negative. We looked at this case is a complete revolution, 2 pi radians. This is 1/4, 90 degrees or pi over 2. This is a positive and it's a negative side. And this is 180 degrees or pi radian, or they call it straight angle. The relationship between 1 degree and minutes, 60 minutes, and 1 minute is 60 seconds. D over 180 is R over pi, omega is theta over T, V is S over T or R omega, S is R theta, A is 1/2 R squared theta. We've seen this, and hopefully everybody's going to remember them, so we need them for the exam as they come across. So that's the case. Also, we looked at the concept of a circle. Remember, x squared plus y squared equals R squared. When the center is located, the center of the circle is at 0, 0. If the radius is 1, it becomes x squared plus y squared equals 1, and that is called the unit circle. And when we are dealing with unit circles, the two that are important, any point, of course, on a circle has coordinates x comma y. X is represented by cosine, y is represented by sine. The rest of them are very easy to figure out. Tangent is the ratio of sine to cosine, and the rest of them are reciprocals. What if we deal with the general case? Instead of x squared plus y squared equals 1, we look at x squared plus y squared equals r squared. Still, we can find the trigonometric functions. In this case, x squared plus y squared equals r, and sine, which was y, now it's y over r. Cosine, that was x, now it's x over r, and the rest follow in the same manner. We looked at trigonometric functions, or the values of common arcs, such as pi over 3 or 30 degrees, pi over 4 or 45 degrees, pi over 3 or 60 degrees. We must memorize this. We must know this. For example, sine of pi over 6 or 30 degrees is 1/2. Tan of pi over 4 or cotangent of pi over 4 are the same as 1. Things of that nature. It is the table here. Hopefully everybody remembers, and we need to be very comfortable with those. Now, we are going to look at the concept of a domain and range of a trig function. And again, sine or f of theta equals sine theta. We have them here. The domain is all real numbers. The same thing for cosine. And all real numbers from -1 to 1. So if we are looking at sine theta, the range is between -1 and 1. The same thing for cosine theta. So let's look at this, okay? And cosecant less than or equal to -1 or larger than or equal to 1. Secant, the same thing. So tangent can go from negative to positive infinity, cotangent between negative and positive infinity. Those are the range. Those are the y values. So here's the synopsis of maybe easier to look at rather than this table. For sine and cosine, same domain, negative to positive infinity, same range, -1 to 1. For tangent, remember what happens. Tangent is the ratio of sine over cosine. So wherever cosine is 0, tangent doesn't exist. It has a vertical asymptote. The range is negative to positive infinity, but the domain is all real numbers, -2 and +1 over pi over 2. Cotangent is the ratio of cosine to sine. So wherever sine is 0, and remember sine is 0 at n pi because pi times n. Secant, it's 1 over cosine, so it's just like tangent. Cosecant is 1 over sine, just like cotangent. We will further investigate them as we go through graphs, but this is the synopsis of domain and range for those functions. It becomes a lot easier when we look at the graphs. All right. Determine the period of a trig function. A function f is called periodic if there is a positive number p such that whenever theta is in the domain of f, so is theta plus p, and f of theta plus p is f of theta. If there is a smallest such number p, this smallest value is called the fundamental period or simply the period of the function f. So this is the angle theta. If we go a complete revolution and we come back to the same terminal side, it's the same angle plus 2 pi. Now, for sine and cosine, 2 pi is the fundamental period. So in general, we call it 2 pi k or 2n pi, where k is an integer. Class B may, in many books, they use 2n pi is the same thing, k or n, okay? That means even multiples of pi. That's the meaning of it. Now, this is any angle, theta, or specifically, let's say pi over 3. If we go a complete revolution and look at the same terminal side, it's pi over 3 plus 2 pi. So what happens is, when we look at the point P with coordinates x comma y, or 1, in this case, specifically 1/2 and square root of 3 over 2, we notice that for sine and cosine, the period is 2 pi, and of course with that goes secant and cosecant. However, what happens in the case of a tangent and cotangent? Remember in the first quadrant, okay, everything is positive, all trigonometric functions. When we go to the third quadrant, right here, okay, remember x and y are both negative here. And because tangent is the ratio of sine over cosine, and cosine is and cotangent is the ratio of cosine over sine, negative over negative gives you the same positive value. Therefore, for tangent and cotangent, the period is pi. So the period is 2 pi for all trigonometric functions except tangent and cotangent. All right, so we are looking to find the exact value of sine, 17 pi over 4. So all we have to do, take out multiples of 2 pi. Okay, you may notice that 16 pi over 4 is the same as 4 pi, right? That means we have gone 2 revolutions 2 revolutions, and then pi over 4. So it's the same as pi over 4. And you know sine of pi over 4 is square root of 2 over 2. Again, it's one of those common arcs. What happens with cosine of 5 pi? Remember, multiples of 2 pi. Again, we're going to take out the 4 pi. So that means 2 revolutions. And you have 1 pi, which means this is the same as cosine of pi. It's one of those quadrantal angles. And the answer is -1. The x coordinate, right? Of this side, right? Of the unit circle. Tan of 5 pi over 4, remember we said in the case of a tangent, if we were to draw that, the tangent in the first quadrant and the third quadrant are identical, and the period is pi. This is larger than pi. Again, notice this is larger than 2 pi. This is larger than 2 pi, so you take out multiples of 2 pi. This is larger than pi. Take multiples of pi out. There is only 1 pi we can take out, and we are stuck with pi over 4. And tan of pi over 4, we know it to be 1. So in short, in the case of all trigonometric functions, take out multiples of 2 pi for tangent and cotangent, multiples of pi. Determine the sign in a quadrant. And everybody remembers that, again, in this quadrant, everybody is positive, every trigonometric functions, because x and y are positive. So let's write what we know. X squared plus y squared is 1. P has a general coordinates of x and y. And as you know, in the first quadrant, everything is positive. In the second quadrant, we're going to write what is negative. So x is negative in the third quadrant. Both x and y are negative. In this case, y is negative. So sine theta equals y less than 0. Cosine theta equals x larger than 0. We are looking at this one. So remember tan theta. As long as we have 2 of them, we can figure out the rest of them. Okay. So again, this represents cosine. And if cosine is positive, so is secant, because secant is 1 over x. Y is less than 0. That means sine is negative. And so is cosecant, because cosecant is 1 over sine. As long as one of them is negative, then the ratio of the 2 is negative. Therefore, one of them gives us tangent, one of them gives us cotangent. Both of them are negative. Tangent is the ratio of y to x, whereas cotangent is the ratio of x to y. But both of them become negative because one is negative. So we have this. Over here, all are positive. Over here, sine is positive, and with that goes cosecant. Over here, tangent is positive, with that goes cotangent. Over here, the fourth quadrant, cosine is positive, and with that goes secant. Or you can memorize it that way. I highly recommend just you remember which quadrant x and y are positive, and if you follow that, you can always figure everything. Now, again, the synopsis of it is here, is here, is here, is here. You don't have to memorize this because it becomes pretty tedious. Just remember x and y in this quadrant, x and y are positive. So if you remember that, let me just write that through. So in this case, you don't have to write anything. Everything is positive. In this case, x is negative. And when x is negative, and let's write y is positive. So basically, y is positive means sine is positive, and therefore 1 over sine or cosecant. In this case, both of them negative, and therefore everything is negative except tangent and cotangent, because there are the ratio of two negative values. In this case, x is positive. So when x is positive, that means cosine is positive, and with cosine goes its reciprocal, secant. All right. If sine theta is positive, cosine theta is negative, name the quadrant in which the angle theta lies. Let's look at each case. Sine is positive. That means the y coordinate is positive. That means we are either in the first or second quadrant. Just stick with that one. Cosine is negative. Remember, cosine is positive in the first and fourth quadrant. So it's negative. That means x is negative. That means the second or third quadrant. So what is in common? Quadrant 2. Fundamental identities. And we have them here, but let's elaborate on those. Here's the unit circle. You're really remembering those values will help you with the quadrantal values of trig functions. X squared plus y squared is 1, and any point with coordinates x comma y, they represent cosine and sine. Okay, so x squared, that means cosine squared. Y squared, that means sine squared. So if we add them up, becomes 1. According to this formula, I'm going to replace the x with cosine, replace the y with sine, and I put it, normally we write sine squared plus cosine squared, doesn't matter. This is one of those fundamental identities. By the way, specific, and we have them here, I'm going to go over the rest of them. And by the way, as far as the terminology, this is called, there are 3 Pythagorean identities. And this is one of them. So this is, in fact, 1, 2, 3. I'm going to quickly show you the other ones. So to prove the other ones, we can divide both sides of the equation either by sine squared or cosine squared. So for now, let's divide both sides by cosine squared. So if I divide everything by cosine squared, what happens? Tan squared plus 1. 1 over cosine is secant, so 1 over cosine squared is secant squared. So this is the second Pythagorean identity. Now I'm going to divide both sides by sine squared. This becomes 1. Cosine over sine is cotangent, so this is cotangent squared. 1 over sine is cosecant, so 1 over sine squared is cosecant squared, and here's the third one. So 1, 2, 3 Pythagorean identities. These two are known as quotient identities. Tan is sine over cosine, cotangent is cosine over sine. These three are known as reciprocal identities. Okay, as far as the terminology is concerned. Again, a lot of identities coming our way. We have to get very comfortable with those. Find the values of the trig functions using fundamental identities. And reminding you of the formulas we had in the previous page. And the name is not that important, but it's good to know this is the set of quotient identities, reciprocal identities, okay? And so in this example, sine is given, cosine is given, and we can use the identities to come up with the rest of them. As you know, when we have sine and cosine, practically we have all of them. So what is tangent? Sine over cosine, sine over cosine. Sine over cosine. This is a complex fraction. We get square root of 10 over 3 square root of 10. Square root of 10 cancels out the square root of 10. We get 1/3. The rest of them, reciprocals. Now we are going to use reciprocals. So from sine, we go to cosecant, 1 over sine theta. It's a complex fraction, 1 over square root of 10 over 10. That means 10 over square root of 10, and 10 over square root of 10 is square root of 10. I'm assuming we have no problem with fractions, complex fractions. So 10 over square root of 10, I hope you see that you can divide 10 by square root of 10 and you get square root of 10, or you may recognize, we can say times square root of 10 over square root of 10, which gives us 10 square root of 10 over 10, and we have that. Either way, secant theta is 1 over cosine theta. So this 10 goes up, right? Complex fraction. As you know, this is square root of 10, so square root of 10 over 3. And finally, this is tangent. Cotangent is 3 over 1, or simply 3. All right, we want to find the exact values. So we have a bunch of identities here. And we are going to use them again. It is extremely important to be comfortable with the identity. So since we have cosecant, and remember, cosecant is 1 over sine. So if cosecant is 1 over sine, 1 over cosecant must be sine. So this is sine squared 35. Sine squared plus cosine squared is 1. So the sum of the two, because these are the same angles, must be 1. Cosine over sine. This is cotangent of pi over 3. So this is cotangent, and this one we repeat, they are identical. Therefore, one minus the other one gives us 0. Well, it works out the same way here. Sine over cosine is tangent. So you write this minus tangent, and both of them are identical. Again, they cancel each other. 0. Tan minus tan is 0. Sine squared of power 12 plus 1 over secant squared of power 12. Generally speaking, secant, cosecant, we go back to sine and cosine. Remember that secant is 1 over cosine. Therefore, 1 over secant is cosine. This is cosine squared. This is cosine squared. Sine squared plus cosine squared equals 1. Finding the values of a trig function of theta when the value of one function is known and the quadrant is known. One methodology is to use a circle of radius r, draw a circle, locate the pair, and remember, any pair P has coordinates x comma y, and r is equal to square root of x squared plus y squared. And you assign the values to two of the three variables, right? Because we have the ratios. For example, sine is y over r and cosine is x over r. And we apply the theorems we just discussed, and if need be, using identities. What do we mean by this? Let me go over a few examples to make some sense out of this. Here's a simple example. We want to find the exact values of all trig functions given the fact that sine theta is 2 over 5 and cosine, we know it to be negative. So what do we need to do? First, let me remind you of all of these formulas. So these are the ones we are going to use. Second, let's figure out the quadrant here. Sine is positive because number 2 over 5 is positive. Sine is positive. Sine is positive in quadrant 1 and quadrant 2. Cosine is negative in quadrant 2 and quadrant 3. What is in common? Quadrant 2. Theta is an element of, by the way, this is class. This is red. This means an element of in the set theory. So it belongs to the second quadrant. That's the first thing. All right. The next thing is to write sine is y over r, which makes it 2 over 5. So we have the y coordinate, we have the r, and x is missing. And we know x squared plus y squared is r squared. So first and foremost, here's theta. This is r, which is 5. And this one has coordinates x, comma 2. Notice we just put x because we don't know the value of x yet. We are going to figure it out. The fact that x squared plus y squared equals r squared can give us the value of x. So x squared plus y squared, that means x squared plus 2 squared. That means x squared plus 4 is 25. That means x squared is 21. If x squared is 21, x must be plus minus the square root of 21. Now, we know that it belongs to the second quadrant. X must be negative square root of 21. So you have to figure out the sign accordingly. And we do. Now just plug it in. You're practically done. We have the value of x. We have the value of y. Take it from there. And the r. So cosine is x over r. And to be honest with you, the rest of them, you can again follow those or just sine and cosine use the identities. We want to use the circles here. We're going to use those. Therefore, tangent y over x. And by the way, I'm assuming from here to here, which is rationalization. Nobody has any problem with that. You multiply by square root of 21 over 21. So this, you have to multiply it by square root of 21 over 20. Cosecant is r over y, 5 halves. That's easy to do. Secant is r over x. Again, we are using the circle. And again, rationalization, multiply by square root of 21 over square root of 21. And cotangent is x over y, x over y. So what did we use? We used the circle and the information that we have here, definition of a sine, cosine, tangent, cotangent, cosecant, and secant. I want to look at the same question. So it's minus square root of 21 over 2. I want to look at the same question. We used unit circles. Now we want to use identities. These are the identities. By the way, the quadrant, we should know it's already quadrant 2. We discussed it in the previous page and with the same discussion, the same quadrant. We're going to use sine squared plus cosine squared equals 1 to find cosine. So we use sine squared plus cosine squared equals 1. And as long as we have cosine, the rest become a piece of cake. So you don't have to go that route. Either way is fine, but you have to know both ways. So sine is 2 over 5 squared. That means 4 over 25. So cosine squared is 1 minus 4 over 25 or 21 over 25. Right? So cosine squared is 1 minus this number, which makes it 21 over 25. And cosine is plus minus the square root of this number, which makes it plus minus the square root of 21 over square root of 25, which is 5. Now, this is what's important. There are two possibilities, but only one of them is acceptable. Now, you go back to this piece of information. In quadrant 2, or actually this is given here. Cosine is negative or quadrant 2, either way. Cosine is negative, so there are two answers. Only negative one is acceptable. There are two answers, only negative one is acceptable. Now, tangent is sine over cosine. Sine over cosine, so this number over this number. And again, rationalization, dealing with a complex fraction right here. We drop the 5, and you get 2 minus 2 over square root of 21. You rationalize it, you get this. A cotangent is the reciprocal of this. Reciprocal of this is easier. Okay, instead of reciprocal of this, look at the reciprocal of this. Okay, class. Sine, the reciprocal of that is cosecant. So 5/2. Cosine, the reciprocal of that is secant. So secant is 1 over cosine, 1 over this. 5 comes at top, and then you multiply by square root of 21 over 21, you get this one. Again, as far as rationalization, I'm assuming we are all comfortable with that, but again, we could go with the circle. We could go with the identities. It's good to know both of them. Ultimately, it's up to you unless they ask for a specific method. All right. Let's look at another example. We want to find the exact values of all trig functions where cotangent is given as 1/3 and sine is negative. And I'm reminding you of these formulas because we want to use circles. Okay, we want to stick with different methods. We're going to do both methods. First thing first, what quadrant is that? If cotangent is positive, one-third is positive, then it's either quadrant 1 or quadrant 3. Okay, quadrant 1 or quadrant 3. If sine is negative, it's quadrant 3 or quadrant 4. So what's in common? Quadrant 3. The very first thing you have to figure out the quadrant where it tells us which trigonometric function is positive, which one is negative. That's extremely important. And because there are two pieces of information, we can always figure it out. Cotangent is x over y. And so you can assume this is the x is 1 or 3, the x is 1 and y is 3. However, we decided it's the third quadrant, then both of them are negative. So pay attention to the fact. We know x over y. You can say this is x, this is y, but both must be positive. And this has got to do with understanding that. If it was the first quadrant, we would use positive 1 and positive 3. Now, x squared plus y squared is r squared. This is 1. This is 9, makes it 10. So r squared is 10, and r is square root of 10, everybody. So in this case, when we do the drawing, we know the pair -1, -3. P has those coordinates. Some theta we don't have, but the value of r was missing that we just calculated, this distance of r. Now we are ready to move on. Tangent is y over x. Again, we are not going with the identities. It's easier to go with the reciprocal and identities, but sine is y over r. Again, I don't want to waste time. We have seen this circle. Y over r, -3 over square root of 10. And then rationalization means multiply by square root of 10 over square root of 10. You get this one. Cosine is x over r. Well, let's do cosecant, which is the reciprocal of that. So square root of 10 over -3. And you normally put the negative sign either at top or in front of a fraction bar, makes no difference. Cosine is x over r minus 1 over square root of 10 and rationalize. Secant is r over x. And pay attention to the sign. As you can see, all of them are negative except cotangent and tangent. Because in the third quadrant, that's what happens. Every trigonometric functional value is negative with the exception of tangent and cotangent. Now, I want to I want to look at the same thing, but this time we're going to use the identities. And again, you decide which one is easier ultimately. But you should be familiar with both methods. So we're going to use the same thing. And we justified that the quadrant was 3 because cotangent is positive. It's the first or third quadrant. Sine is negative. That makes a third or fourth quadrant. And therefore, the common would be quadrant 3. I hope everybody can see how we find that. You find this one has 2 possibilities. This has 2 possibilities. The one in common becomes the answer. Again, quadrant 3, right? And quadrant 1. Quadrant 1 and 3. Let's write that because I want to make sure that we are comfortable with that. This happens in quadrant 1, quadrant 3. Let's actually spell out 3. This is negative in quadrant 3, quadrant 4. In common goes quadrant 3. Now, as far as the identities are concerned, we are going to use one of those Pythagorean identities. You may remember that sine squared plus cosine squared equals 1. Tan squared plus 1 is secant squared. Cotangent squared plus 1 is cosecant squared. And that's what we are going to use here. Let's plug in what we have, which is cotangent. Find the missing cosecant. And of course, we have 2 answers. We figure out the sign in a moment. So this is 1 over 9. And we add it to 1, makes it 10 over 9. Okay, 1 over 9 and 1, 10 over 9. So cosecant is plus minus the square root of this number, which is plus minus the square root of 10 over 9, plus minus square root of 10 over number 3. There are 2 answers. Which one do we choose? In quadrant 3, cosecant, just like sine, is negative because cosecant is the reciprocal of sine, so it has the same sign. So cosecant is negative. Or better yet, in quadrant 3, all of them are negative except tangent and cotangent. Now that we have cosecant, well, cosecant, sine is 1 over cosecant, so cosecant is 1 So sine is 1 over, cosecant is 1 over sine, so sine is 1 over cosecant. So the reciprocal of this becomes sine minus 3 over square root of 10. Rationalize, you get this number. I'm assuming again, let me quickly show you. All you have to do, multiply this one by square root of 10 over square root of 10. Simplify and you get this. Since cotangent is 1/3, that means tangent must be 3 over 1 or simply 3, the reciprocal of that, right? So identities perhaps make it a tad easier. Now, remember, tangent is sine over cosine. Why is this important? We have the value of sine. We have the value of tangent, so cosine is missing. And I hope you realize if you have a fraction like that, you can put the cosine here, tangent here, because in essence, it's the cross product. So cosine is sine over tangent. So sine is this, negative 3 square root of 10 over 10. Tangent is this. And clearly, this cancels out this one, and this is your answer. And secant is the reciprocal of cosine. So the reciprocal of this is the last one. Secant theta is 1 over cosine. So the reciprocal of this comes up, this goes down. And 10 divided by square root of 10 is square root of 10. The negative sign remains. We are done. I'm assuming we have no problem with the fractions and evaluation of fractions. Let me know if there is a question. So we could evaluate all the trigonometric functions using circles, where x squared plus y squared equals r squared. And for example, sine is y over r, cosine is x over r, and so on and so forth. Or we could use the identities such as sine squared plus cosine squared is 1, tangent is sine over cosine, secant is 1 over cosine, all those identities. Two different methods. Use even odd properties to find the exact values of the trigonometric functions. Every trigonometric function is an odd function except cosine, and with that goes secant. I want to make sure we understand what's happening. So I want to look at cosine only. Cosine of negative theta is cosine of theta. That is the meaning of even. If you replace the theta with negative theta, nothing happens. And secant is the reciprocal of cosine, it works. But if you have sine of minus theta, is minus sine theta. Tan of minus theta, minus tan theta, and so forth. And why is that? If you look at theta versus negative theta, see x and y. X doesn't change, y changes. So because x doesn't change, everybody, the cosine doesn't change. With cosine goes secant. So pay attention to this. Theta, change it to negative theta. X comma y becomes x comma negative y. X remains unchanged, cosine remains unchanged. Secant is the reciprocal of that, that remains unchanged. Everything else will be negated, okay? Everything else will be negated. Obviously, sine is y over r, and this y is positive, this is negative, and so do the rest of them. Tangent becomes y over x, cotangent becomes x over y, and so all of them are odd functions except cosine, and therefore secant. All right, so I want cosine of negative 60 is the same as cosine of 60, and therefore I should know it's one of those common arcs. The answer is 1/2. Sine of negative 390. I can take the negative sign out according to this. And then this is larger than 360 degrees. Please understand 2 pi radians is 360 degrees. Since this is larger than 360 degrees, we're going to take off 360. So this is the sum of something and 360, which is 30, right? So now, because the complete revolution, because it's a period of sine function, this becomes minus sine of 30. As you know, sine of 30 is 1/2. So with the negative becomes negative 1/2. Over here, the same thing. Tan of a negative is negative of tan, which means we are looking at this, everybody. Right? It's an odd function. And we know this number is larger than not only pi, even 2 pi. So we just take out multiples of pi, because the period for tangent and cotangent is pi. So you may recognize 37 is 36 divided by 4 plus 1 divided by 4, and 36 is divisible by 4, and this is 9 pi. Again, this is just basic math. 37. Notice you want to divide by 4. So in essence, when you divide this, okay, you can think of this as 9 and 1/4, class. So in essence, this number is 9 and 1/4, and that's the 1/4, if you will. Are you with me? Or this one. Therefore, this is negative tan of pi over 4. You know tan of pi over 4 is 1, so this is negative 1. Using even and odd properties of trig functions. Okay, if cotangent theta is negative 2, find cotangent theta plus cotangent theta minus pi plus cotangent theta minus 2 pi. Recall the period for tangent and cotangent is pi. When we say pi, any multiple of pi, positive or negative, makes no difference. So this is cotangent of theta, so is this one. Again, any multiple of pi will do. Negative or positive makes no difference. So therefore, 3 of those. 3 times negative 2 is 6. So 3 cotangent theta, each one is negative 2 times negative 2 gives us negative 6. Find the exact values of those. Sine of 1 plus sine of 2 plus sine of 3 all the way to sine of 359. So we can keep those. Notice this is 360 minus 1. So it's the same as sine of minus 1. 360 minus 2, sine of minus 2. 360 minus 3, so sine of minus 3. Okay. Now, we want to write what's in the middle as well, because we want to show if there is anything that is left. So If this continues to 180, then we have all the way to sine of 179 and sine of 180. And then it goes down. First of all, this becomes negative. This becomes minus sine of 3 degrees. This becomes minus sine of 2 degrees. This becomes minus sine of 1 degree. So if we put all the way in between, all the way to 180, let's see what happens. Take a look. We have those three, and then we go to sine of 179. We go to sine of 180. And after that, when we go beyond 180, becomes minus 179, because I want to make sure we understand why it's minus. Because this one is plus sine of 181. And 181 is 360 minus 179. So it's sine of minus 179. So minus 170, minus sine of 179. So as you can see, everything cancels out. This cancels out this one. This one cancels out this one. This cancels out this one. This cancels out this one. So what are we left with? Sine of 180, sine of 180, or pi, we know it to be 0. Let's do the same thing with cosine and see what happens. And since we did this in the previous page, we repeat the same thing in essence. So again, since we've done that in the previous page, this is what we get, meaning, let me just grab my, they don't change. This becomes 360 minus 1. So cosine of minus 1. 360, let me write a couple of them here. So this is 360 minus 1. 360 minus 2. Okay, so, and you can get rid of the 360, right? It's a complete revolution. 360 minus 3. And as you know, cosine is an even function. So cosine of negative 3 is the same as cosine of positive 3. Same thing for negative 2, same thing for negative 1. So what do we have? Let's write it. It means we have 2 cosine 1, 2 cosine 2, 2 cosine 3, all the way to 179, and 1 cosine of 180. Okay. So we have 2 cosine 1, 2 cosine 2, all the way to that. So we have 2 of each, all the way to 179. And then we have cosine of 180. Now, 179 is 180 minus 1. This is 180 minus 2, and so forth. And here's what I want you to pay attention to. Cosine of 1, whatever the answer is in the first quadrant, is positive. Cosine of 180 minus 1 has the same reference arc 1, except in the second quadrant, cosine is negative. So these two are identical. One of them positive, one of them negative. This one is positive, this one is negative. All of them cancel each other. We end up with cosine of 180 only. And cosine of 180, we know it to be negative 1. All right. From a parking lot, you want to walk to a house on the ocean. The house is located 1,500 feet down a paved path that parallels the ocean, which is 500 feet wide away. Along the path, you can walk 300 feet per minute, but in the sand on the beach, you can only walk 100 feet per minute. See the illustration. The time t to get from the parking lot to the beach house can be expressed as a function of the angle theta. Shown in the illustration and is as shown, as follows. Calculate the time t if you walk directly from the parking lot to the house. Here's the formula. The time is time as a function of theta is 5 minus 5 over 3 tan theta plus 5 over sine theta, where theta is between 0 and power 2. So what we want to do, we want to figure things out. So this is 500 feet. And again, this may not be to scale, or this may not be to scale. And this is 1,500 feet, okay? And this angle is theta. And that means clearly we can calculate the tan of theta, which is the opposite over the adjacent, 500 over 1,500. 500 over 1,500 is 1 over 3. And if you want to go with the concept of circles is y over x, if you want to go with that concept. Or you can go with identities, you can calculate the r. There are different ways of doing that. Anyways, x squared plus y squared is r squared, where x is 3, y is 1, and they add up to 10. Therefore, r is square root of 10. Or simply put, again, you can make this small. You can square this, and take a Pythagorean theorem and calculate this value. But if you go with the ratio of 1 over 3, it's easier. If you square that, it works out with the same ratio. Not the same number, but the same ratio. Sine, okay, so this is r square root of 10. This is theta. And therefore, sine is 1 over square root of 10. Sine is the opposite over the hypotenuse. Again, if we go with 1 and 3, we can go with 500 and 1,500 and calculate that. There's nothing wrong with that. It's just those are huge numbers. It's easier to deal with smaller numbers. So we have the tangent, we have the sine. So plug in everybody. So t is 5 minus 5 times 3 times 1/3 plus 5 over 1 over square root of 10. This obviously is 1. So 5 minus 5 cancel out. This is 5 square root of 10. And 5 square, so these two cancel each other, right? So this is the exact answer. And use a calculator, and it gives you 15.8 minutes. That's it, class.